guys, Miss Miklos here, and in today's lecture we are going to be talking about evaluating polynomial functions. And we're going to talk a lot about what common types of polynomial functions are and kind of go through some vocabulary that you should know but maybe don't quite know. So first, our degree, if we have a degree of 0, we call this type a constant. Okay, so we say it's constant when our degree is 0. I know that if our degree is 0, our number of roots is also 0 because we learned that the degree is the maximum number of roots. In standard form, we will often see this as f of x, and we know this is just function notation and it means y, equals a naught. So when we have this subscript of 0, we call that naught. And an example of this is something like y equals 2. Okay, so we know this is just a horizontal line that is not going to cross the x-axis at all. Our next one, when we have a degree of 1, we call this linear, and if something is linear, we know that there is one root. And linear functions are what you guys spent the most time talking about back in Algebra 1. And if I wrote this in standard form, I would get something like f of x equals a sub 1x plus a naught. And an example of this would be something like y equals 2x minus 1. Okay, so that would be a linear function which we are used to. Our next type of function is what we call a quadratic function, and we used this all last chapter, and that is when our degree is 2 and we have 2 roots. Our standard form for a quadratic function is f of x equals a sub 2x squared plus a sub 1x plus a naught. And if I was going to go ahead and write this, this could be something like y equals x squared plus 2x minus 3. So far, these are the types of functions you guys have spent a lot of time working on in math. Degrees of 3 and 4 is going to be something kind of new. So let's go ahead and look at those. If something has a degree of 3, we say that it is cubic and it has 3 roots. If something has a degree of 4, we call it quartic and it has 4 roots. If anything has a degree of 5 or up, we actually just refer to that as a polynomial. So some examples of this in standard form is just continually adding on this first new term. So f of x equals a sub 3x cubed, and then it continues downward. And a quartic one would start with a sub 4x to the 4th and then continue down. Some real life examples of this could be something like y equals x cubed plus 8. And you guys might be wondering, well, what happened to x squared and x? Those coefficients can always be 0. This is still a cubic function because our degree is 3. An example of a quartic function could be something like x to the 4th plus 2x squared minus 7. And I know since my highest degree is 4, it would be quartic. So on our problems, it's asking us to do a few things. Label the following type of polynomial function, label the leading coefficient, and then go ahead and evaluate. Okay, so if I'm looking, part A here, since my degree is 4, I would go ahead and say this is quartic. The second thing, we know that the leading coefficient is the coefficient on the highest term. So in this case, our leading coefficient would be 2, because 2 is the coefficient of x squared. Finally, I need to go ahead and evaluate, so I'm going to do f of 3, and we know that this means wherever there's an x, I'm replacing it with a 3. So 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. So going through this, I have 2 times 81 minus 8 times 9 plus 15 minus 7, which is 162 minus 72 plus 15 minus 7, or 98. So once again, this is not a super difficult concept. It's something we've done a lot of before. We just need to be really meticulous in substituting in wherever there's an x. This is actually what we call direct substitution. And this is really the only way up until now you guys have learned how to use substitution. And today we're going to be learning that there's actually another way to go ahead and evaluate, and it's something that we call synthetic substitution, and it actually is exactly what it sounds like. Normally when we hear the word synthetic, we think fake, so this is kind of like a fake way to use substitution. So the very first thing that I'm going to do is fill in all of our missing terms with a 0. So I'm going to think of this as f of x equals 2x to the 4th plus 0x cubed minus 8x squared plus 5x minus 7. The next thing I'm going to do is write all of our coefficients out in a line. So in this case it would be 2, 0, negative 8, 5, negative 7. And I'm going to draw a little box, and I'm going to leave like a line of space and draw a line underneath. In this problem, I'm going to go ahead and put 3 in the box because that is what I'm substituting in. And so now we have our synthetic substitution all set up. And the way synthetic substitution goes, I'm going to bring down my first term, which is 2, and I'm going to write a 2. And now it's going to be a repetition where I'm going to multiply. 2 times 3 is 6, and add. 0 plus 6 is 6. And now I'm repeating over again. 6 times 3 is 18. Negative 8 plus 18 is 10. 10 times 3 is 30. 5 plus 30 is 35. 35 times 3 is 105. Negative 7 plus 105 is magically 98, which is the same exact number we got when we used direct substitution. Okay, so on our homework tonight and on our walkthrough tonight, you guys are going to be using this concept of synthetic substitution. And this concept of synthetic is something that we actually use a lot through the chapter. So let's just kind of recap what we did again. I looked at our polynomial and I filled in any missing terms with a 0. I wrote out my line of coefficients and put whatever we were substituting in for x into the box. I brought down my first number, then multiplied, added, and so forth until I got an answer of 98. So let's continue on with number 2 here. So number 2, if we look at this, it looks like my highest exponent is 3. So we're going to say that it is cubic. My leading coefficient on that x cubed term is 5. And then I need to evaluate. So I'm actually going to use synthetic substitution here. So there's my box. I know I'm going to put 4 in there. And it's going to be 5, 1, negative 4, and 1. I wasn't missing anything that time, so I can just go ahead and write out my coefficients. So I have 5 down. 5 times 4 is 20. 1 plus 20 is 21. 21 times 4 is 84. Negative 4 plus 84 is 80. 80 times 4 is going to be 320. 1 plus 320 is 321. So what we really just did, whatever we're putting in here is our input, so that's like a function, and whatever we get down here is our output. So let's just do one more example. This time, I have something pretty large. I have x to the 5th, so we're just going to say that this is a polynomial. Next, I know my leading coefficient is 3 because x to the 5th has that degree of 3. For part C, I'm going to put 2 in our box, and I'm going to start writing out my line of coefficients. So I have 3. I don't have an x to the 4th, so I need 0, X cubed I don't have, so I'm going to have to put 0. -2, 1. I'm also missing a constant, so I'm going to have to put 0. So it's really important wherever I'm missing a term, I need to fill in a 0. So now I'm bringing down my 3. 3 times 2 is 6. When I add, I get 6. 6 times 2 is 12. When I add, I get 12. 12 times 2 is 24. When we add, we get 22. 22 times 2 is 44, which gives us 45. 45 times 2 is 90, and when I add, we get that our answer is 90. So hopefully this gives us a brand new way that we can use substitution. On our test, it's really open. You guys can use either method. It's just kind of nice to learn something new.